chapter 7. I'm showing you a lot of graphs and diagrams and pictures, as many pictures as I can. Am I showing you the 100% of the story? Probably not. Even those of you that work with boilers and have boilers under your care are available for you to have a look at when you go back to work. You might find these are little short videos. They're all listed here in the we likely won't have time to look at them tonight, so possibly on Thursday, we'll see. But if you have a chance to look at these videos, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all like 2 minutes long. I think maybe the first one is the longest one, might be 3 or 4 minutes. What they show you is the inside story. They have a camera inside a boiler, and you can see what happens when different operating conditions are investigated. Learning objectives for this chapter: low level fuel cutoffs, low cutoffs for fuel in the case of no flames, testing and maintenance of those devices. We'll look at feed water float switches, operating valves and float switches that operate pumps, and we'll look at some feed water and condensate piping arrangements and equipment. So the very first thing in the glossary at the beginning of the chapter is one of the things on the glossary, which is the first thing in the beginning of the chapter. I continue to remind students, if you see a glossary, you might glance down and say, oh, I know what this is and I know what that is, so I'm not going to bother to read that glossary. There's certain jargon used in power engineering. The terms that are used for things are often specific to power engineering. Something from some other trade or other field might be described differently. And if you're asked the question, what is the definition of this? That question has been taken from this glossary in this textbook. So for the term of the course and up until exam day, it's highly recommended that you learn the jargon in the glossaries in the textbooks. I reviewed an exam today. A 4th class student from Peace River had he was passing his exam, his supervised exam, but didn't have a great score, and most of the questions that he picked completely wrong answers. They were answers that were understandably logical in terms of if you work in a different field. The way things are stated in the textbook needs to be kind of wrapped around in your brain until exam day, and then you can go back to what you know is the actual fact in the field. Okay. A mercury switch. These are common devices in controls and especially level controls. As I say that, they're actually being phased out because of problems with this stuff. This is not something you want to have in the environment or in your garbage bin or in your torn down old plant. So we're getting away from mercury, but we're going to learn all about them. There are on a boiler, there's probably 10 or 15 of these devices normally. And it's a switch. It's a common switch. It's a very reliable switch. They prove to be completely reliable devices, but so you need to understand how they work, because they make up a big part of keeping the boilers safe and operable, right? We don't go to a boiler and take them out and get rid of them, but as we replace equipment, we put in switches that are not this kind of a switch. What is a mercury switch? It looks like this. This is about an inch long, inch and a half long. It's a glass bulb. There are electrical contacts inside. You see two wires coming into this envelope. That's an electrical contact. How do we open or close that contact? Mercury is a metal that's liquid at atmospheric pressure and normal temperatures. And if this device is tipped over to the left, the switch is what?
Closed.
It is not closed. There's no contact. Tipped over to the left. Yeah, the brain tries to do that. So over on this side, we have it tipped over to the right. The contact is made, the contact is closed. So we're going to turn something on. So switch is closed, we're going to turn something on. And if the switch is open, we're going to turn something off. Okay, if this switch is closed like it is on the right, the gas valve will be energized and fuel will flow. When fuel is flowing, we need to ignite it. When we ignite the fuel, we want this to stay in the closed position, and it would only go over to the open position if something goes wrong. And we'll look at half a dozen different things that can go wrong. So most gas valves are solenoid valves, and this is from your glossary at the beginning of the book. A solenoid valve is an electrically operated valve. It has a coil, which means it's uses electromagnetic fields. And what that means is turning on this solenoid pulls some kind of a metal plunger with a magnetic field, and generally it's going to open the valve. So coil is energized, moves a plunger attached to a valve disc, opens up the gas flow to go through to allow us to start up our boilers, and many, many other things too. But most cases, we're going to be talking about solenoid valves allowing a flow of gas or some other fuel into our boiler. A main cause of heating boiler failures, we're going to look at a few causes. Most importantly, we're going to look at one that is due to low water conditions. So we looked at that boiler here, and we pointed out that we need to make sure that these heating surfaces, being a fire tube boiler, the tubes are the heating surfaces. They must be cooled to water temperature. They cannot be at steam temperature. Up here in the steam space, the temperature is going to be a lot hotter. And we do that by having a minimal level of water covering the tubes, okay? When the water level gets to the bottom of the gauge glass, we're still going to have about at least an inch of water over top of the top heating surface or top tube, okay? When that video we saw where the boiler exploded, it blew the ends off of it blew an end off of the boiler, or the boiler was propelled out through the wall of the building and moved 30 meters. This is probably a 30 or 40 ton boiler, a medium-sized fire tube boiler. Moving that thing through a wall and another 30 meters is quite the explosion. So extremely lucky that people were not killed. So important to think about and remember, one of the easiest ways to blow up your boiler is overheating of the surfaces. So the heating surfaces get too hot because we have a low water condition. When low water occurs, metal temperature will weaken. Internal pressure can burst the equipment. It can burst and not do a lot of damage, but if it does burst, there will be damage. Your boiler will be out of commission, at least that boiler, if not all the boilers, because of the incident where we looked at that video. And so we're going to talk about low water fuel cutoffs and some other things tonight. This chapter is low water fuel cutoffs to minimize this risk, okay? If water gets too low and our fuel is shut off, we're in a condition we can't blow up the boiler, okay? One of the things about low water fuel cutoffs, you need to construct it and install it so that it doesn't have a way to isolate it or render it inoperative. Okay. Sometimes there's provisions so we can test it under operating conditions. And usually the simplest test is simply lower the level in the boiler until the fuel cuts off. Okay, there are some instances, we'll talk about what they are. There might be two on boilers. Boilers that are not under constant supervision will have two low water fuel cutoffs, because we want to at least not have the paperwork for a boiler explosion. Okay, main cause of heating boiler failure is overheating of the surface due to low water conditions. Metal, high metal temperature weakens the metal, it softens up, it gets very weak. And the pressure, even a 100-pound boiler, 100 pounds pressure, a very severe boiler explosion occurred in BCIT, Vancouver Trade School boiler. It was a boiler in the instrumentation side of things, 175 PSI, completely destroyed the boiler building. And also, very lucky there was no fatalities. So what is a low water fuel cutoff? The purpose of a low water level fuel cutoff is to shut off the fuel supply if the water level gets too low. So the basic style is a float type. This is part of the device. It shows a round brass or copper ball in this case. And this is simply floating in the liquid. So this is our water level gauge glass. The device, the low water fuel cutoff, forms a column here, a level column. So these guys are connected over to our boiler. Top and bottom, steam side and water side. Water level should be somewhere in the middle of the gauge glass. So water level should be about here. And when you see a device like this in the field, you'll probably see a line on the side. Generally, it's about the middle. I see a line on this one about 1/3 from the bottom. And if this float drops down where the level is close to the bottom of the sight glass or gauge glass, that's when we're going to shut off the fuel. Okay, the device has this float and an arm connected to some kind of a switch box or junction box, and in here is contact. So what a contact is part of an electrical control circuit. It's a type of switch. Generally, the switch is the mercury switch that we looked at earlier. Okay, so here's our float chamber. This one is connected to the boiler, steam side at the top, water side at the bottom. Internally, it has a floating in the level of the water. I would call this approximate level where cutoff point, or the bottom lowest permissible level. It's a mechanical device. It has a lever, goes up towards this contact, and this contact here is a mercury switch. Important to remember, we have steam in here. and also very hot water in the bottom. So what sort of relationship between electrical contacts and steam and hot water? What do we want to keep them apart? Probably a good idea. So this one has a flexible bellows or diaphragm in here to prevent that steam from getting up here in the electrical part of the device. And this is the other type, so a diaphragm or a bellows, one or the other. So here's the mercury switch, tip to the left, no contact. Here's a mercury switch with two contact sets in it. Sometimes we can also control the feed water control valve or pump with a second set of contacts. 3-wire double pole switch uses a cutoff for fuel and then another contact for an alarm switch. So it can start a feed water pump. It can open a feed water valve. It can turn the fuel off and on, and it can sound an alarm depending on the arrangement of switches and contacts. And most commonly, it's that mercury switch. Inside the mercury switch that we saw, can't see it, filled with inert gas, or just under vacuum. When a glass tube is constructed for that kind of service, where there's electrical devices inside, they have it's actually a tiny little charge. They heat the thing up when they melt it to close the ends, and this little charge will literally burn up the air inside, and then that creates a vacuum, and then those contacts are less likely to corrode from the action of especially oxygen inside the glass bubble. So to review, the internal float follows the changing water level. This guy moves up. Everything is good. This guy moves down too low past this line. That's going to turn off the electrical current to the solenoid valve and stop the flow of gas. When the float drops due to a low level, circuit power is interrupted or opened, causing the fuel valves to close. Water level in the chamber is the same as the level in the boiler, so this should be approximately in the middle, connected to the steam at the top, connected to the water in the bottom, some kind of switch. Classically, mercury switches, but you'll see one with a big label on it. This one contains mercury, and you'll see one with a label on it. This one does not have a mercury switch. And remember, there's a bellows or diaphragm right in here, so we don't get any steam or hot water up in the device. Combination pump control. So if it's labeled as a combination pump control, this one will probably have an alarm level, alarm switch, and also start the feed water pump to add more water as the level flow drops down. The next diagram shows 3 different levels in this device. So A is the first paragraph on the right. Feed water supply switch opens when the level goes below A, and when the level is above A, it's going to stop the feed water supply. If the water drops down to B, feed water supply switch will close and feed water will be resumed. C, or cutoff switch, opens the power to the fuel valve. So if we get this low, we're going to stop the power to the fuel valves. So the switch should open at line number C. If the level stays below C, the boiler can't be started unless the level comes up above C. If the level does come up above C in this range here, then the boiler will either be able to be started or in some instances, they will automatically restart. So here's one in the wild, and this is on a hot water boiler. And you see it says this product is now mercury free. So this one won't have mercury switches in it. It has different kinds of switches. There's 3 videos here. This type is, our brand is McDonnell Miller. It's a very reliable, classic type of low water fuel cutoff you'll see in the field quite often. So there's 3 different videos here to have a look at how they work and how they're hooked up and things like that. So a 2-minute one, a 5-minute one, and another 5-minute one. There are other types. I've seen these electrode type devices installed, and I've seen them uninstalled a year later. And we go back to good old classic McDonnell Miller type. Okay, just so you're aware, there's other types, but they've not proven to be reliable. So if we had a hot water heating boiler in these chapters, we're going to mix up hot water and steam a bit. We'll try to keep it clear. Why would we have low water level? Well, a lot of these will apply to steam boilers, but specifically in chapter 7 on page 8, it talks about these kinds of conditions. So chapter 7 has a glossary with the solenoid and mercury switch. I was looking at the wrong glossary. It was much longer in chapter 1, but make sure you read them all. Some leaking going on. Something breaks or something's corroded. Something's allowed to leak. Too much blow off. We've got problems with safety valve. Hot water boiler safeties do not pop open. They do not cause a big ruckus in the boiler room. So they can be leaking away. And if you're not carefully checking your equipment, you might find your water level keeps dropping annoyingly. And this is one of the causes, kind of unique to a hot water heating boiler. Relief valve discharge caused by overfiring on hot water boilers for different reasons. Some things are not calibrated well. And you just might have a boiler feed pump failure or autofill valve failure. So all of the above. Hot water heating boiler can have low water cutoffs in different places. So this one shows it on the boiler. This one shows one on the return piping. Anytime water level in hot water boiler, hot water heating boilers specifically, goes below 100%, you need to shut it down. These systems need to be 100% full of water all the time. So any of these locations will take the burner down and won't let you operate until you replenish the water. And there's the low water cutoff on the boiler itself. Hot water devices can just be very simple sensors, such as this one, the low water fuel cutoff. Okay. So any column or chamber, we talked about the level columns with the gauge glass on the side. Low water fuel cutoff device is also a column or a chamber, so it has a drain. Because should debris build up in the bottom here, which will happen eventually, it's going to collect and interfere with that float. And it could be keeping the float from falling down low enough. So We will do a blowdown of the chamber, or the column by draining it periodically. The textbook recommends weekly. Some of the videos you'll see will recommend it every shift. Back in the day, we went out to the boiler with our relief and we blew it down and we shut it down to prove that that system was working. Every shift change. So, textbook says weekly. If you have boilers, you have your own procedure, but this is the one I would note for future reference. Reliable method of testing is just simply lower the water level in the boiler. Different ways to do that. Some blowdown of the drain, some blowdown of the column. Won't actually lower the level in the boiler, but it will stimulate a low water condition, and you can observe that the burner shuts down, and then close the drain and let it start up. So one method is simply lower the water level. You may isolate the feed water going in. You may slowly shut it back, watch the level drop, keep an eye on the gauge glass, and note when this device shuts down the burner. Page 7.9 has some sort of recommended testing and maintenance of, and what it does is it starts out, it says daily, it says weekly, it says monthly, and it says annually, and then in some of the paragraphs, okay. Page 7.9 starts with steam boilers, and we have daily, weekly, monthly, and then on page 7.10, it talks about hot water boilers. So kind of the similar checklist, just things that are different between steam and hot water boilers. So steam boilers, routine checks, as normal, just pay attention to stuff, right? If there's leaks or abnormal conditions, I just remembered something in my crystal ball. I have one floating around my head that gets clear once in a while. Something that's usually missed when operators are doing routine checks or normal operation. Use your ears. Okay, if something sounds different, there's probably something going on. Okay, if you're an experienced operator, you'll know what I'm talking about. As you get more experience in operating equipment, you will learn to pay close attention, and even the vibration. You go up on the boiler deck and it's got a certain vibration. Something is changed, that vibration can be different. Weekly, so remember it recommends in the textbook a weekly blowdown of the low water fuel cutoff drain while the burner's running. We're gonna do a test, right? So we're gonna open the drain, and we should see the fuel shut off somewhere above that lowest permissible level. It should shut off when we can still see some water in the glass. If it goes right out of the glass, I'd be reaching for the big red button. If it blows out of the glass and does not shut down the burner, you need to shut that burner down immediately, and then find out what's going on. It's possible there's build up in that chamber. And while doing that test, you're clearing the sediment from the chamber. And checking burner safety and startup operation. So once you see it shut down, reverse what you did to make the level drop. And then you should, as the water level comes back up, you should see the system go into startup. Okay, monthly, also shut off the feed pump or supply valves and simulate low water conditions. And annually, you're going to do a lot more stuff, okay? And if it's hot water boiler, daily, sort of same as steam boiler, check all the normal stuff. Pay attention to sounds and noises. Weekly drain the float chamber to remove sediment. Nothing specific for monthly. If you're doing all the checks every day and every week, you should be good per month, and then more stuff every year. Most heating systems will be shut down summertime outside the heating system and go into a turnaround or yearly maintenance. And I think more and more there's major maintenance only done every other year. That's all about saving money, right? Combined functions. So page number 712 specifically talks about, it actually starts on page 711. Page 711. Combination low water fuel cutoff and feed water supply switch. Most steam heating boiler feed water supply is controlled by a float switch. Float allows fluctuations of the boiler water level rather than using a separate float and housing. The feed water control is commonly operated by the low water fuel cutoff. So you'll have a device like this with more than one switch in here and these different functions. So one switch will control the pump, another switch will cut off the fuel. If the fuel gets cut off, there should be an alarm to a control room. It's often a siren or a buzzer right in the boiler room, right on your boiler control panel. If the boiler goes down, there will be a horn that blows to warn you. And then the lines on here, at A, the pump shuts off. At B, the pump comes on. If the level goes way down to D, the burner fuel is cut off and won't be restarted unless the level goes back up to this height. And be aware some of these devices in certain situations, they have you'll see a little lever on the top. And if they're tripped to under certain conditions, you can't start the boiler unless you reset that trip. If a boiler is equipped with a combination feed water control that also controls a low water fuel device, the burner cannot be restarted until level goes up above the C line or level. And what that means, another way to say that, you might see it talked about in this jargon, the level must be restored above the cutoff line before the unit can be restarted. And sometimes it refers to cutoff line. You'll see a line on the housing of the device. This is a good video on that McConnell-Miller type level device. Okay. 712, they start to talk about a basic plant. So we've got a steam plant layout. If a steam boiler is not continuously attended by an operator, then it must have two low water cutoffs, so an additional device. Okay, one of them is a low water cutoff and the other one is a cutoff, pump control, and alarm switch. Steam systems create steam. If it's a heating plant, it's sending steam out to convectors and radiators and unit heaters with steam exchangers. We're going to condense that steam back to water to take that latent heat out of it and heat up our spaces, our buildings, our processes, our equipment. And then what's called condensate is going to return or come back. So we're going to have some kind of a condensate receiver. We'll look at these condensate systems as we go through these chapters. So this is a condensate receiver or a condensate tank. Notice there's also a low water switch on here. Let's call it a low water switch instead of a low water cutoff to be less confusing. And this tank feeds a pump. And this pump is called our boiler feed pump, and that's where the water comes back into the boiler to make up for the level of the steam going out to the system. Let's make this a radiator here. Okay. Float operated low water fuel cutoffs. Float operated device has a float and a valve. And this is a combined assembly, controls the flow of feed water into the boiler. So this device primary function is supplying the feed water. There would be a second fuel cutoff device to shut down the boiler. So that as this float moves up and down, it's going to increase and decrease the amount of feed water flowing through to the boiler. So there would need to be another float type device that will shut the burner down if this thing doesn't keep the level up where it should be. Combination type. So just a couple of the devices you'll see out in the field. If device like the float operated one we saw is a second source of feed water is controlled by low water fuel cutoff and different kinds of feeder valves, the second source should open before the low water cutoff one. So if we have a backup source, this mostly applies to hot water heating, and we don't expect a hot water system to lose level continuously. We have a full 100% sealed system. There are always leaks and things. So a little bit of water disappears. We need this second source. Generally, it's city potable water. And that needs to be opening up before we actually trip the fire on the low water fuel cutoff. Okay, second source should open first. And starting on page 713, it talks about this, and we look at some different types of systems. And we just mentioned this, so here's our makeup water from the city. Feed water control cutoff combination device. Actually, this one is a steam boiler. So this one has steam. Occasionally we're going to need, normally we get enough condensate coming back. Occasionally we're going to have a need for makeup water to open up. More of an emergency situation, and it needs to open before we shut down the burner. Sometimes we have an electric inlet valve on that city water supply. So this one here has the supply coming in, a block valve and solenoid valve. Secondary switch controls power to an electric secondary water supply valve. Anytime we're connected to city water supply, there needs to be backflow prevention. And we look at backflow prevention. We looked at it briefly in chapters before now, and we have later on, we have a detailed look at backflow prevention. If you look it up or you remember it or you've seen a connection like this to a boiler, you'll remember what that backflow is all about. We don't want this boiler water to go back out into the drinking water for the city, right? Float operated mechanical feeder valve. If it's a float operated valve, it shouldn't open till the level is below where the feed pump cuts in. Also need to have backflow prevention. Okay, you should not open until level is below the feed pump cut in. So this device has a line here. This is a flow controlled feed water valve. You have a question, Richard, or shall I mute you?
No.
You're good? Okay. When water level drops below normal operating level, float will open. If it cannot maintain the water level, so this is a combination feed water. If it doesn't open up wide enough to keep the level, then it will shut off the fuel. Feed water basics. So 716 feed water connections. Boilers produce steam or hot water. So we're looking at both types. And a perfect system, every kilogram of steam or water leaving the boiler would be returned to the boiler. As I've just mentioned a few times, it doesn't always work that way. Steam boilers will lose water from routine and normal blow off and blow down. And so the steam heating systems also lose some water. There are always some leaks and usually some outside process where we consume some steam, some kind of a steam system for tracing and things like that. Hot water systems shouldn't lose any water, but there will be occasional need for replacement water. So the water fed to a boiler is called boiler feed water. And generally, this applies to steam. Okay, the hot water circulating in a hot water system is the same water going out, the same water coming back in. It's our heated water. If we're calling it boiler feed water, if we have a condensate receiver, it's going to be referring to the water coming back from steam heated equipment. Okay, if it's hot water system, we're going to call it return water. If we call it makeup water, it's additional supply. Generally, that city water tie-in to replace any excess losses outside of what we're returning to the system. Steam transfers latent heat of evaporation into our heating process and it reverts back to its liquid state. By taking that latent heat from the steam, we condense it back to liquid, then we have something called condensate. Typically, our condensate is very pure water. It also contains considerable heat. It could be between 80 and 100 degrees C. We've used up what we can, most of what we can. We like to recover every drop of that water because to make water that's clean from river water or even from city water, if our supply is city water and we want to make it very clean water to put in a steam boiler, it's a very expensive process. It's not cheap to make pure water. So we like to think that we can collect every drop of condensate and bring it back to our system. So very important to recover and reuse condensate. If a greater volume of condensate is reused, less raw water needs treatment. If we treat less water, we use less chemicals, and we don't need to build a big expensive treatment plant or operate it. Condensate has also got heat in it. It requires less boiler heat to raise its temperature. So having a hot condensate is kind of a good thing because it increases the efficiency by decreasing the amount of fuel we need to burn. And if we burn less fuel, we have less less emissions, less pollution. So to kind of recap, a steam boiler sends out steam to process our heating system. It's condensed and returns as the feed water. In a hot water boiler system, we send the heated water out to the system, and most of it, 99%, should return and recirculate around and around in the system. Sometimes we have small amounts of makeup water to replace the losses that end up occurring. So a kind of a basic steam system. We've got our boiler. We're boiling water. The boiler is coming in here from the boiler feed water pump. And it's entering the boiler. And we're going to boil away, heat it up, create some steam. Steam is going to wherever we're using it. We use it to heat buildings and processes and equipment. And then it comes back as condensate into a condensate return tank. And then we pump it from a condensate pump. A small system, this would go back to the boiler. And medium and larger systems, we take this condensate. Part of the treatment for the condensate is to put it through a deaerator. And really in a deaerator, we just heat it. We'll talk about this when we get to water treatment to remove gases. So the gases are removed through the vent. We use some steam to heat the water in the deaerator. So some of the produced steam is going back to the deaerator. Most of the produced steam is sent out to the process. And then this becomes our boiler feed water. Okay, so very simple, basic flow diagram. When we have municipal water for makeup for a steam system, we need some treatment. We need to do some softening of the water. This comes up in a much later chapter, what we do with these things. But this is the expensive part, right? If all of our condensate comes back, we need minimal water treatment, just a little bit of softening for some water. And hot water system, so we've got a hot water boiler. Hot water boilers will have circulating pumps or circulators. They will supply different zones. There might be one pump to many zones or many pumps for many zones. So hot water is going out to different places. We take the heat out of it. So here we're heating some other fluid or liquid. Here we've got radiators heating up our zones or rooms, and then water returns at a cooler temperature and comes right back into our boiler. So we might have a manifold here for other zones on the system. But all of this water comes back. Okay. Well-designed condensate system. So back to condensate, meaning we're talking about steam systems. Well-designed condensate system has a condensate receiver. The receiver should be big enough to hold the volume of condensate equivalent to water evaporated by the boiler in 20 to 30 minutes at normal load. If you didn't have a big enough receiver to collect the condensate, all of the condensate comes back. That would be an undersized receiver, and it would have to overflow to sewer, and you'd be giving away that very expensive pure water that could be reused. And we need to know that we need a makeup system should our condensate system fail. If our makeup system is going to open to keep us running, we need to have enough capacity in that makeup system to supply water at the normal firing rate. Normal would probably be considered 100% firing. Different ways to bring that water back to condensate back to the system. Well-designed system has a big enough receiver and reliable method of makeup, generally big enough to supply. And in this one, it said 20 to 30 minutes. Guess what? That's the same as 1/3 to 1/2 hour of operation at normal load. And the makeup valve, so if our condensate doesn't keep up, we need to open this makeup water valve, which is the city water supply. It should be able to maintain enough of a level to keep operating at normal conditions. External float valve. So this first one was page 716, and then we jump over to a different type. Just a really small difference here. This has a float inside the valve. I found some better pictures of this today. So the valve is the same for the makeup feed water from the city. Float inside the tank is called an internal float makeup valve. If the float is on the outside, it will actually result in a smoother flow of makeup water. A condensate receiver having condensate coming back in and being pumped out at the same time, this level can be kind of bumpy in here. So with an internal float valve, we're going to have a bumpy supply of water, right? If we put the makeup float valve on the outside of the tank, we can put some equalizing lines to dampen the fluctuations in the chamber, resulting in a smoother flow of makeup water. And if it's a bigger system, we need a bigger tank, and we need a big enough valve to supply for makeup water for normal operating, usually 100%. And then external float valve is the preferred type because it has that smoother flow of makeup water. And I have a closer look at equalizing lines. So we're connected at the top, we're connected at the bottom. Level in the tank is bumpy. The level in here will be much smoother, and control this float valve to give us a smooth flow. So what this shows you is the float type that goes right in the tank. If the float was in here, we'd have that bumpy conditions, not so smooth for flow. Another type is on page 717. So a hydraulic controlled feedwater valve. City water supply is connected here, and we have a makeup float, external float. And when this float if this level drops too low, this float will open a line up to a hydraulic valve controlled by a diaphragm. So that will allow the city water to come in and make up for inadequate water supply here coming in. Okay, remember all these tanks have a pump. Got a pump, and we got water going to our boilers, boiler feed water. Flow control opens, the pressure will drop and cause the diaphragm valve, this one here, diaphragm or hydraulic type feed water inlet valve. And on the last page of the chapter, 718, they show a Modulating feed water valve. So it's an electric or motorized type valve. So there's a signal from a controller that's on a float, external float. The signal goes to this motorized valve and opens up a motorized valve when needed. So it's different than a solenoid valve. Solenoid is electrical, turns on, opens the valve, turns off, closes it. Modulating control valve is an electric motor that will open the valve to 10% or 25% or 50% or wide open when needed. Mentioned on the last page, 718, a condensate receiver low water cutoff switch. I had a better picture, but if this has a switch from the controller, it will control the operation of the pump. If this level just goes too low and makeup doesn't keep up, the feed water pump will be shut down to prevent damage to the pump. A little review of chapter 7. Long chapter, longest chapter. Low water fuel cutoff will shut off the fuel if the water level is too low. Low water fuel cutoff could be activated or tested by lowering the water level in the boiler or simulating a lower water level in the boiler. Result of undersized condensate receivers could mean that we lose the condensate to the sewer. Not a great thing. Equalizing lines on a condensate receiver float chamber will dampen level, the bouncy level. It will smooth the flow. Mercury switch under high vacuum to prevent corrosion of internal contacts. Okay, so inside here should be an inert gas such as nitrogen or vacuum, no air. Main cause of boiler failure, low level causing overheated heating surface. So we're going to look at a different kind of boiler failure, but I want you to get this one kind of stuck in your head, and then we'll look at some other things in other chapters. So overheating, this one here, okay? What's wrong with answer number 2? Furnace explosion is different. Okay, blowing up the furnace is one thing, blowing up the boiler or pressure parts is another thing. And we'll clear that up tonight. What's wrong with this answer? It's going to cut down on it happening, but do these devices work 100% every time? Maybe not, right? And this one's not right also. This one's wrong. This one's wrong. We can overheat surfaces. We can run the hot water boiler low and cause something to fail. So cannot occur is not true. Remember, low water fuel cutoff, shut off the fuel if the water level is low. Shuts off the fuel if the water level is too low. Okay, nothing to do with water pressure. Does not necessarily control the water level. Some have a combination device and does not. Low water fuel cutoff, you would not want that to shut off the water supply. Okay, that's off the fuel. Switch separated from boiler pressure with what?
Float gauge.
Diaphragm.
No, flexible diaphragm. Okay, this is something different. not the packing, not the siphon. Why is there a vacuum in a mercury switch bulb?
Prevent corrosion.
Absolutely. Thank you. Reasons for low water level in boilers. Leaks caused by breakage or corrosion, excessive blowdown, automatic feed water valve passing. Is that correct? That would be a high level. Okay, passing means leaking. It means it's not shutting off. And another reason for low water level of feed pump failure. Okay. So we're talking about steam boilers. Hot water boilers do not have feed pumps. They have circulators or circulating pumps. They don't always have feed pumps. Flow chamber of low water cutoff blown out weekly to what?
Clean out the chamber.
Yeah, blow out the debris, blow out the sediment, prevent collection of sediment. How do you do that? Just simply open the drain. Okay, there will be a procedure. If you don't want to test the system, there will be some kind of a bypass, a red button to hold. Back in the day, we had jumper wires. You could look around and connect. Don't mess around with that these days. But there might be a specific procedure. Blow out the low water cutoff float chamber periodically. The book says weekly is a good idea. It recommends weekly. I recommend you remember weekly as the answer. How to activate a low water fuel cutoff, and this would be a test. And students continue to select this. This is not a way to lower the level. This is a way to check the level. Okay. Surface blowdown would not be a way to lower the level. Lowering level in the sight glass is not the answer. And lowering level in the siphon, no. I'm going to lower the water level in the boiler. All right. This is a way to activate it as a test. If the boiler is equipped with combination feed water control and low water cutoff, that shuts down due to low water, the level must be restored to above the cutoff line before it can be restarted. Second source of supply water must open before the low water cutoff is reached. 715, so we're talking about mechanical float operated feed water should not open until the level is below the feed pump cut-in level. All right. Condensate receiver should be big enough to supply water to run this long. And the makeup system should be able to supply. So when this system stops, can't keep up, this system should satisfy normal firing needs. Where does the condensate in the condensate receiver tank come from? Where does the water in here come from? Normally.
Condensate tanks.
This is the condensate tank.
Okay.
This system does not have or need a deaerator. This system is supplying steam to these radiators, and condensate is coming back. So it's coming back from the heating system. Okay. This one doesn't have a deaerator. If you have a deaerator, that's where that water will come from normally. Deaerator can be bypassed for maintenance. Float chamber equalizing lines. So they look like this. They're connected above the level and connected below the level. They dampen the level fluctuations. Okay. Got that one. So our float can move up and down smoothly. Okay. If the float is inside the tank, it's going to be less than smooth. If your condensate receiver has a low level cutoff, it is to stop the feed water pump. If a pump is run without liquid coming in, it's going to be damaged. It's going to be damaged quickly. Low water fuel cutoff, float can operate the low water fuel cutoff switch and feed water control switch. Okay. Overheating of heating surfaces due to low water level is a main cause of heating boiler failure. And this can happen fire tube, this can happen water tube, this can happen steam boilers and hot water boilers. Any questions on chapter 7? How's everybody doing? All 43 of you. Wow. Chapter 8, heating boiler operating controls. We're going to look at some methods of controls, some types of controls. Some of these are exclusive, some of these are combinations. Lots of things to think about, but we're just going to really touch on the high points of these 4 things. So on-off control, simply start the burner, temperature or pressure gets to where you need it, burner stops. Pressure or temperature slowly falls off, gets to a point in a control system, calls for more heat, start the burner. On-off control. There's no high fire, there's no low fire, there's no modulation, it's on or off. Most systems run most efficiently when operated at 100%. So power on when you need it, power off when you don't. We'll also look at high fire, low fire type control. We'll look at modulating control. We talk about what a high limit control is. Specific situations on top of these control systems, there will be a high limit control. So on-off starts and stops the burner to maintain the pressure. If this is a steam boiler, it's going to look at pressure. It's going to start and fire the boiler at a constant rate. When upper pressure limit is reached, the burner is turned off. Pressure will drop and swing down to the lower limit, and the burner will be turned back on. And a controller that does that looks like this. Somebody see something familiar in here? It's a mercury switch. Okay, there's the mercury switch. Pressure is connected down here at the bottom. Pressure is connected into these bellows. So the bellows is sealing the steam pressure from coming into this box. Higher pressure causes the bellows to literally get bigger. It gets longer, it expands when it's got more pressure inside, pushes up on this lever. When we push up on this lever, we tip the mercury switch over the other way and then shut off the burner. When the pressure drops down, the lever tips down to the right. Mercury switch tips over, mercury touches the contacts and starts up the burner again. This device is a little more, no, it's the same device as this one. So this one has a way to adjust the pressure. So if we loosen and tighten the spring here, we can change the relative tilt, and it adjusts the point where this switch makes the contact, it starts and stops the burner. So we can set it at 12 PSI or 15 PSI. When we have a device like this, without this side, the differential adjustment, the boiler will tend to start, stop, start, stop, start, stop. It's gonna start at that set pressure, and then it's it's gonna stop at that set pressure, and then it's gonna start up right away. So we add something called a differential. And what this does is it puts a difference between startup and shutdown so that we have more time not running. Cycling is reduced. So this starting and stopping is called cycling. We reduce cycling by obtaining a larger spread or difference between the cut-in pressure or the cut-out pressure. So this extra spring adds tension to the main spring, causing a differential between startup and shutdown. Remember that these devices are connected with a siphon. They don't get connected directly to the, if on a steam boiler, okay? Connected with a siphon on a steam boiler. If we're measuring pressure in a boiler, it's because it's a steam boiler. When we have a hot water boiler, we run it on the temperature, water temperature. This device will often have a leveling indicator. This is just a level or a lever that ensures the device is level so that it operates with the right correct relative angles in here for this thing to work at the right setting. Some examples of cut in and cut out points. This is from page 8-6. And talking about high and low fire control system. Okay, so two pressure controllers. The controllers are similar to on-off, but there's going to be two because we have two nozzles. We have a low fire nozzle and we have a high fire nozzle. And some numbers here are for examples only. High fire nozzle is in continuous operation when demand exceeds the boiler output. Should we set our demand very high, this system will turn on the big high fire nozzle and it will continue to run. And the system just won't ever get high enough to cut out. Okay. High or low fire control, one controller for pressure, and the second controller selects the high or low burner. So there'd be a controller for pressure and a second controller. So I see no siphon on these controllers. So what does that indicate to you? What kind of boiler is it?
Water heat.
Yeah,
Heating
water, a water boiler, hot water heating boiler, yeah. Two controllers, and then this just shows the relative settings on a particular boiler. High fire nozzle is in continuous operation when steam demand is greater than the boiler can keep up with. So you would switch the control to automatic after the boiler warms up. Variations in pressure cause the bellows to expand and contract. This one is modulating or resistance control. So it should change the order of these slides. So page number 8-7, modulating or resistance control is a control system where variations in pressure cause the bellows to expand and contract, as it would in any type. And this operates a lever, and instead of the lever tipping a mercury switch, it will move contacts across an electric resistance coil. The variable current created by using this resistance coil will drive or control a modulating motor. And what a modulating motor does is it controls gas and air flow simultaneously. So if you see a motor like this, there will be a lever. Generally, the lever kind of goes across, and we'll have a gas valve on one side and a connection to an air damper on the other side. So as this air and fuel are adjusted, they're moved simultaneously. So here's the electric coil. As the bellows is increased in pressure, it moves a wiper across a resistance coil. And here's a picture of that again. And what's important to know about modulating control is it uses a modulating motor, and that motor adjusts the air and gas flow together. If a steam heating boiler, steam heating boiler is not under constant supervision, so if somebody is not in this boiler room all the time, an additional control is required. That's called a high limit control. Shall be equipped. That means the code specifies steam heating boilers not under constant supervision. I'm just going to write down this slide to fix that typo. 20. High limit pressure control will shut off the fuel supply at the maximum allowed pressure for a heating boiler, okay? Which is 103 kPa, so about 15 psi. Okay. High limit switch or control's purpose is to shut the burner before the safety lifts, should the operating limit control. So operating limit control is the one that's operating to the limit that we set. High limit control is set above that. So an additional device that will trip and shut off the burner and will likely need to be reset before we can start up. If the operating limit control shuts off the burner, it's going to start up again. It's going to start up again when the pressure comes down to that setting, right? So these are two separate. Operating limit control is the might be on off, might be modulating, and might be high and low setup. If that fails or doesn't keep the pressure below this number, then this high limit switch will shut down and won't allow the system to start up by itself. And this shows you some examples. If you have the high operating limit on a hot water boiler, and we want hot water temperature around 82 C, we're going to have things cutting in at 82. It will cut out at 77. Sorry, cut out would be 82. So another typo in here. Cut out at 82, cut in at 77. If it had high-low fire control, it would be set at these numbers, and modulating control would be like this. And if any of these failed, it would reach that 88 and stop the system. So it might be on-off or modulating control, a specific type of control for hot water heating systems. So starting on page 8-8, you can see a device called an Aquastat on 8-9. And Aquastat has a capillary tube connected to a sensing bulb, and this is typically a brand name Aquastat. I think Honeywell has actually bought out Aquastat now, and they call it a Honeywell Aquastat. You'll see them back in the day, they were all labeled the brand name Aquastat. They often just say Honeywell on them, and they have a model number. Feature of this kind of a system, it's a closed liquid-filled system that actually operates a pressure switch. So the closed system part of it is called the thermal element, and the thermal element expands and converts that temperature signal to a pressure signal. And here's that Aquastat. It senses water temperature to turn the burners off and on. And I think it says here it can be on off or modulating. All right. There's the Honeywell Aquastat. And then other brands are on the market now. So you have a set point. Where do you want to operate your water temperature? And this will start and stop your burners or modulate the burners to control the water temperature in a hot water heating system. Commonly used on smaller boilers, sensing bulb is connected to the bellows with no capillary tube. Different in design, controls the burner circuit in the same way. I just have to make a note here. Aquastat, how's everybody doing? Good so far. So far, so good. Still have 43. And it will cut off the fuel supply at a maximum allowable temperature of 121. So these things can be set wherever you want to operate, but you can't operate it above this 121. And if you go to page number 3-4, remember I said I have a big, you'll see that a hot water heating boiler must not exceed 121 degrees. That's right out of section 4 of the heating boiler code, operation of heating boilers. Okay, important feature to remember, sensing bulb reacts to boiler water temperature and cuts off the fuel supply when the temperature reaches the set point that you set on the dial on the device. Burner switch, some stuff about on-off manually operated switches. We looked at that, we talked about that. There's also something called a damper positioning switch if we have high-low firing or modulating control, to position for high-low or modulated in that kind of control system. Boilers will have automatic manual selector if we have a modulating system. Flame control switch used in conjunction with the auto manual, and high and low fire switch. Okay, we'll have a closer look at all the switches. Something called a low air pressure cutoff switch. So this is kind of an interlock or a safety. Normally open type switch that will shut off fuel supply if air supply fails. In later chapters, we're going to see that we supply combustion air with different methods. There's different kinds of fans. There's forced draft, induced draft, balanced draft. Sometimes atmospheric burners. This kind of a switch would not apply to an atmospheric or convection supplied combustion air. But if we have forced draft fans supplying combustion air, we need to have a part of the control system that senses that airflow. So if the fan is running and supplying air, it will hold contacts in this kind of a switch closed to allow a chain of interlocks to complete a circuit and allow the system to run. Should that fan stop supplying air, for example, a coupling breaks or a fan belt breaks, motor would continue to run, but no air would be supplied. If the fan is continuing to supply pressure, the switch will stay closed, and if the air supply fails for any reason, the fuel will get shut off. Okay. If combustion air pressure drops too low, which switch will de-energize or turn off the fuel belt? The one we just looked at, the low air pressure switch. And description of testing one of these, when I type testing a low air pressure cutoff switch and into Google, it came up with a video where a guy had an old frying pan and he put it over the fan outlet to test a switch. Proper procedure is slowly covering the air supply to the fan. So he didn't have it too wrong. This would actually work. So other safety switches in a system: low air pressure fuel cutoff shuts off fuel supply if the air supply fails. Low gas pressure fuel cutoff shuts off fuel supply if fuel pressure drops too low. High gas pressure fuel cutoff. So low gas pressure to a system is a bad thing. We have an interlock to shut things down. High gas pressure is equally as not desirable, equally as bad. We need to shut off the fuel supply if gas pressure gets too high. Burners are designed for a specific gas pressure. They will work effectively and efficiently and keep burning. If pressure is too low, they won't work well, risking a flame out. If pressure is too high, we could blow the flame out and cause problems for ourselves. So the same kind of a switch works on low or high gas pressure cutoff. It works much the same as the air pressure switch. It has the diaphragm sensing the pressure connected to the pressure down here. And opens the switch if the spring pressure is not overcome by gas pressure. Testing of these controls, operating and high limit controls, tested regularly to ensure proper operation. Generally, a startup procedure will include testing of the different interlocks. You'll start up a part of a system, you'll shut something down. You'll start up two more parts of the system, you'll shut something else down. And when you're doing the testing, you observe the cut in and cut out points. High limit control can be tested. There will be some kind of bypass of the operating control. That could be a bypass button that you have to be standing there holding, or you will have electricians or instrument mechanics come and set up the conditions for a test. Ensure the boiler stops before. If it's a high limit control, it needs to stop above the operating point, but also below the safety valve setting. And any equipment, controls, and other things should be kept clean, checked for corrosion and wear and problems, and regularly tested. How to test a high gas pressure fuel cutoff. During operation, just quickly close the main burner shut-off. So we got a high pressure switch here, and we can just shut the gas down and ensure that the sorry, we wouldn't shut the gas down there. You have a high pressure switch, we would shut off the manual valve beyond the high pressure switch, quickly close it, pressure would spike and shut down the high gas pressure switch. Starting up boilers with high-low fire control, the manual high-low switch should be switched to low for warming up and starting up, and then we switch it to high once we've got things operating. Testing and maintenance, manual high-low switch to high or automatic once the boiler is warmed up. An aquastat senses water temperature, uses a temperature signal to push a switch open or close with pressure. Low air pressure fuel cutoff checked when the airflow was maximum. And if a boiler is not under continuous supervision, we have code requirements to add a high limit safety device to that system. On-off controlled steam boiler operates most efficiently at continuous fire. If we could design our system to be the perfect size for all conditions, we could run it flat out all the time. That would be the most efficient. But sliding contacts moving over electric resistant coils will vary the electrical current to a modulating motor if you have the modulating firing control system. On-off boiler operating control switch has a differential spring and setting to reduce cycling. Manually start and stop the operation of most boilers with just simply the burner switch or the on-off button. A burner switch. So one of the switches here will say burner switch. Methods, all of the above. On-off control, high-low fire control, modulating control, and high limit control. So I didn't check this one off because this is not a control system of its own. This is a system that's added to any of these systems when the boiler is not under continuous supervision. So you need on-off control plus high limit. You need high-low fire control plus high limit. You need modulating control plus high limit if the boiler is not continuously attended. On-off steam boilers. So a little review of chapter 8. Operates most efficiently at continuous fire. Okay. If it's a steam boiler, it's not going to cycle based on temperature. The steam pressure won't be constant. The steam pressure will go up when the burner's on, and then the burner will shut off at the set point. The pressure will drop down, and then it will start up again when the pressure hits the cut-in point, and then the cut-out point, and then the cut-in point, and then the cut-out point. So that does not maintain constant pressure. And on-off is not the way we operate multiple boiler systems. Okay. The best answer, operates most efficiently at continuous burn. Leveling indicator is on that on-off control switch. Okay. High fire nozzle on multi-burner setup will operate continuously when steam demand exceeds capacity. Okay. Manual high-low switch should be switched to high or automatic when the boiler is properly warmed up. Two of these are true. Resistance or modulating control does what? Uses a modulating motor. Uses a modulating motor by adjusting electrical current to operate that motor. Okay. High limit control used when a boiler is not under continuous supervision. It must open a switch to shut the burners off before the safety valve opens. Purpose of a high limit temperature control.
Shut down the burner.
Yeah, this one here, shut down the burner. Shut down the burner if the temperature rises too high. So keyword temperature. High limit temperature control. If the temperature is too high, it's going to shut down. Hot water system controls. Hot water boiler operating control can be a pressure switch. Uses a closed liquid filled system. This is an aquastat. Aquastat uses this thermal element. This is a liquid filled bulb. Liquid heats up, creates a higher pressure, and that pressure moves a switch inside the device. Hot water boiler operating control could be a pressure switch that uses a closed liquid filled system. So important things to remember about a hot water controller. Aquastat senses the water temperature. High limit temperature control on a hot water boiler shuts down the burner if the water temperature rises too high. And it must do that before the safety relief valve lifts. If you simply want to manually start and stop a boiler, use the burner switch. Combustion air safety switch used on boilers with forced draft fan. Not gas boilers only, could be oil fired, and not something you'd find on a natural draft boiler. Natural draft is not strong enough to trip any switches. And that switch looks like that. It has a diaphragm in the middle, and it has combustion air connected to one side, and the other side is connected to the atmosphere, basically an open tube, and it compares atmosphere to fan outlet pressure and shuts off, opens the circuit when the airflow fails. Fuel gas pressure gets too high, the high gas pressure cutoff. It's, where is it? High gas pressure switch will open a switch to stop the boiler to test the high gas pressure cutoff. Quickly close that main gas valve. So you'll spike the pressure to the switch and shut the burner down. Okay, high limit control of a steam heating boiler should activate between the set pressures of the operating control and the safety valve. Okay. In the back of the book, there's some questions on 16 and 17, good questions. I don't recommend all of the questions in the book. There's lots of other questions for you to answer. But sometimes I glance through the ones in the chapters and I'll recommend them to just check them out. And probably all the answers are in the stuff. All the answers are in the stuff we just looked at. Any questions on chapter 8? So 8 was a little shorter. 7 was a longish one. 8 was a little shorter. 9 is not too bad, and then 10 will be pretty quick. Flame